Hello and welcome to the science class. My name is Teacher John. I'm going to take you through science, primary 7, term 2. The topic is simple machines and friction. Last time we looked at levers. Remember, we are looking at classes of simple machines. And the first class we looked at was simple machines. The first class we looked at was levers. So today we're going to look at inclined plane. And inclined plane is also known as slope. Inclined plane is also known as slope. And what is an inclined plane? An inclined plane is a slanting surface. An inclined plane is a slanting surface. An inclined plane is a slanting surface. Any surface that is slanting can be described as an inclined plane. Now, how are inclined planes important in our daily life? Maybe before we look at importance, let's have a look at examples of inclined planes. Examples of inclined planes. Examples of inclined planes. Examples of inclined planes. One, we have winding rod. Winding rod. So a winding rod is an example of an inclined plane. Then we have staircase. Staircase, the one we call steps that help people to move upstairs. Then we have what you call ladders. Ladders. We say staircase is also known as steps. Steps. Steps or staircase. Then we have ladder. A ladder is an inclined plane. Then we have what we call ramp. A ramp is also an example of an inclined plane. So we have winding rod, ramp, ladders, staircase. So those are some of the few examples of an inclined plane. You can even add wooden plank. A wooden plank. Wooden plank. These are examples of inclined planes. Now, how is an inclined plane important in our daily life? Importance of inclined planes. Importance of inclined planes. Importance of inclined planes. One, they help people to move upstairs. They help people to move upstairs. For example, a staircase. One can climb a tall building using a staircase or steps. Then ladders help people to climb tall buildings or to climb trees. Then winding roads help people to move in mountainous areas, or winding roads make movement in mountainous areas easy. So that's how inclined planes are important in our daily life. Ladders help people to climb tall buildings. Ladders help people to climb tall buildings. Or to climb tall trees. Staircase make movement upstairs easy. Staircase make movement upstairs easy. Then a winding road makes movement in mountainous areas easy. A winding road makes movement in mountainous areas easy. A winding road makes movement. A winding road makes movement upstairs easy. A winding road makes movement upstairs easy. Then wooden plank helps in loading and offloading goods on vehicles. Wooden plank A wooden plank is used for loading and offloading. Helps in loading and offloading. Helps in loading and offloading heavy goods on vehicles. Offloading heavy goods on vehicles. So that's how inclined planes are important. Ladders help people to climb tall buildings or trees. Staircases help or make movement upstairs easy. Winding roads make movement in mountainous areas easy. Make movement in mountainous areas. Winding roads, or a winding road makes movement in mountainous areas easy. A winding road makes movement in mountainous areas easy. Then lastly, a wooden plank helps in making or helps in loading and offloading heavy goods on vehicles. So that's how an inclined plane is important in our daily life. And how can inclined planes be made to simplify work? How can an inclined plane be made to simplify work? How can an inclined plane be made? How can an inclined plane be made to simplify work? To simplify work. One is by making the slope longer, So when you make the slope longer, less effort is used to overcome the load. When you make the slope longer, we end up using less effort to overcome the load. Next we look at mechanical advantage. So that you can write NB. The longer the slope, the less effort is used to overcome the load. The less effort is used to overcome the load. So when the slope is longer, less effort is used to overcome the load. I've said we look at mechanical advantage. This mechanical advantage can be abbreviated as MA, mechanical advantage. Now, mechanical advantage is the number of times a machine simplifies work. Mechanical advantage is the number of times a machine simplifies work. Mechanical advantage is the number of times a machine simplifies work. So if a machine can simplify work 2 times, it means that the mechanical advantage is 2. You can also say mechanical advantage is the ratio of load to effort. Mechanical advantage is the ratio of load to effort. Mechanical advantage is the ratio of load to effort, which means mechanical advantage equals to load out of effort. This is what we mean by mechanical advantage is the ratio of load to effort. And mechanical advantage has no units because it is a ratio. Mechanical advantage has no units because it is a ratio. Then another thing you need to note is that friction lowers the mechanical advantage. 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 So we do some calculations. John used a slope to raise a load of 60 kg force from the ground to a higher level, as shown below. Calculate the mechanical advantage. It can also ask you to find the load distance, effort distance, and so on. Before we look at that diagram, we can look at example 1 or examples about calculations of mechanical advantage. Examples on calculations. 1. Jen used or Jen pushed Jen used the effort Jen used the effort of 60 kg force to pull a load of 30 kg force. Find the mechanical advantage. Find the mechanical advantage. Jen used the effort of 60 kg force to pull a load of 30 kg force. Find the mechanical advantage. We shall say mechanical advantage equals to load out of effort. Mechanical advantage equals to, our load is, Jen used the effort of 30 kg force to pull a load of 30 kg force. So our load is 30 kg force and our effort is 60 kg force. Here we shall say Jen used the effort of 30 kg force to pull a load of 60 kg force. 60 kg force. So our load will be 60 kg force and our effort will be 30 kilogram force. So this kilogram force, they cancel, 0 cancels 0, 3 here 1, 3 here 2. So our mechanical advantage will be equals to 2. Remember we said mechanical advantage does not have units because it is a ratio. So Jane used the effort of 30 kilogram force to pull a load of 60 kilogram force. Find the mechanical advantage. Example number 2, you can say a man pushed a wheelbarrow carried 80 kilogram force on a wheelbarrow. A man carried 80 kilogram force on a wheelbarrow. He used the effort of 40 kilogram force. Find the mechanical advantage. Find the mechanical advantage. Okay, we are saying a man carried 80 kilogram force on a wheelbarrow and he used the effort of 40 kilogram force. Find the mechanical advantage. He said mechanical advantage equals to load out of effort. This man used the load of 80 kilogram force and the effort of 40 kilogram force. Kilogram force and kilogram force, they cancel. 0 cancels 0, 4 here 1, 4 here 2. So the mechanical advantage equals to 2. And as I said, mechanical advantage does not have units because it is a ratio. Mechanical advantage does not have units because it is a ratio. So our mechanical advantage is 2. As simple as that. So the mechanical advantage is load out of effort. Mechanical advantage is load out of effort. Then we can have example number 3. John used a slope to raise a load of 60 kilogram force. John used a slope to raise a load of 60 kilogram force. John used a slope to raise a load of 60 kilogram force from the ground to a higher level as shown below. From the ground to a higher level as shown below. So this is a slope. This is a slope. This is the slope or the inclined plane. This is 4 meters. Then the slope is 5 meters. The slope is 5 meters. So this is point A, point B, then point C. So John used the slope to raise a load of 60 kilogram force. So a load of 60 kilogram force was carried a load of 60 kilogram force was carried from point B to point C using a slope or along the slope. So you work out or find the following. Work out the following. Work out the following. Part A, the load distance. The load distance. Part B, the effort distance. The effort distance. Then part D, part C, the mechanical advantage. The mechanical advantage. Now, if you look at this inclined plane, point A to point C is the load distance. Point A to point C is the load distance because it's the vertical height. Now, the load is supposed to move from point A to point C. But because if you carry the load from point A to point C, you use more effort. That's why we use an inclined plane. That's why we use a slanting surface, so that we can use less effort. So part B to C. B to C is the effort distance. B and C is the effort distance. A and C is the load distance. So our load distance is 4 meters. The load distance is 4 meters. Then the effort distance is 5 meters. Effort distance is 5 meters. Now, we want to calculate the mechanical advantage. We said mechanical advantage is load out of effort. But remember, in this diagram, we've not been given the effort. We only have the load. Therefore, the formula is going to change, and we shall say mechanical advantage is equals to effort distance divided by load distance. Mechanical advantage is equals to effort distance divided by load distance. So we shall say mechanical advantage is equals to effort distance divided by load distance. Effort distance divided by load distance. Our effort distance is 5 meters and our load distance is 4 meters. our load distance is 4 meters. We say cancel and our mechanical advantage will remain 5 out of 4. That is the mechanical advantage. That is the mechanical advantage. Let me give you another example. Another quick example. You can say, all right, let's continue. Let's look at another example. We said Elena used an inclined plane below to carry the load from point A to point C. Point A is here, point C is here, then this is an inclined plane. Then C to B is 6 meters, A to C is 3 meters. So we are asked to find the following. We are asked to find the effort distance. Now, effort distance is the distance through which the effort moves. Then the load distance is the distance through which the load moves. As I said, the load is supposed to move from point A to point C. But if you carry the load from point A to point C, because it's a vertical height, you use more effort to carry the load from A to C. Now, instead of carrying the load from point A to point C, we put an inclined plane. We can put a ladder, we can use staircase, we put an inclined plane which is point C to point B. So this one will help you carry the load using less effort, because an inclined plane is a slanting surface. It helps us to carry the load using less effort. So they ask you to find the effort distance. Effort distance is B to C, which is 6 meters. So the effort distance is 6 meters. Then the load distance is 3 meters. Load distance is 3 meters. Can come and say A. We said effort distance. Effort distance is 6 meters. Then part B, load distance. Load distance is 3 meters. Load distance is 3 meters. And I've told you the load distance, the distance through which the load moves. The effort distance, is the distance through which the effort moves. We'll move the load from A to C, but because we shall use more effort, instead we carry this load through B to C. If we use this distance, effort distance, we shall use less effort. And that's why we shall use effort distance. So the effort distance is 6 meters, load distance is 3 meters. Then part C, you are asked to calculate the mechanical advantage. Mechanical advantage. But I told you, mechanical advantage is load out of effort. But because we've not been given effort, we only have the load, we cannot use that formula. We shall change the formula and say mechanical advantage is equal to effort distance divided by load distance. Mechanical advantage is equals to effort distance divided by load distance. You only use load out of effort if you've been given both load and effort. If you've been given the effort distance and the load distance, then you use mechanical advantage is equals to effort distance divided by load distance. So we shall say mechanical advantage equals to effort distance, out of load distance, out of load distance. So our effort distance is 6 meters and our load distance is 3 meters. Meters comes with meters, 3 here 1, 3 into 6, 2. Then we shall say mechanical advantage is equal to 2. Mechanical advantage is equal to 2. And I told you, mechanical advantage does not have units because it is a ratio. So the units cancel out automatically. That is all about mechanical advantage. Next we look at wages. Wages is going to be our next subtopic. Wages. What is a wage? A wage is a cutting tool. It is also called a double inclined plane. A wage is a cutting tool. A wage is a cutting tool. A wage is a cutting tool. Or you can say a wage is a double inclined plane. Any cutting tool you know is under wages, or is an example of a wage, like a panga, an axe, a knife. All those are examples of wages. So we look at examples of wages. Examples of wages. We have so many. Examples of wages. One, we have an axe. An axe is an example of a wage. An axe. Then a panga. We have panga. We have knife. An axe, a panga, a knife, a hoe, a slasher, all those are examples of wages. A razor blade, a razor blade, a razor blade, a razor blade, a nail, a needle, a nail, a needle, and so on. So all these are examples of wages. Why are they called wages? They are cutting tools. We look at uses of wages. Uses of wages. How are wages important in our daily life? Uses of wages. Uses of wages. You can say an axe is used for splitting firewood. An axe is used for splitting firewood. A panga is used for cutting small trees. Number 3, a knife is used for peeling food. Then matoke, peeling food, like matoke, sweet potatoes, and so on, is used for peeling food and so on. A razor blade is used for cutting fingernails. Slashing is used for cutting. A slash is used for cutting tall grass. A hoe is used for digging, and so on. So that's how we give uses of wages. Then a needle is used for sewing clothes. Then we have what we call a wooden wedge. Number 9 here, you can add wooden wedge. This wooden wedge is used for splitting firewood. This is how it looks like. A wooden wedge. So this one is a wooden wedge. It is used for splitting firewood. So those are the examples of wedges. As simple as that. Examples of wedges. Next, we look at screws. 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 A screw is an inclined plane wound round. 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 And this is how a screw looks like. So this is an example of a screw. A screw is an inclined plane wound round. Examples of screws. Examples of screws. Examples of screws. Number one, we have spiral staircase. Spiral staircase. Number two, we have car jack. Car jack. And a car jack is also known as a screw jack, also known as a screw jack. So an example of a screw. Then we have a screw nail. A screw nail. A screw nail. Screw nail. So these are examples of screws. We have spiral staircase, car jack, and a screw nail. I think you've seen screw nails. We can now look at uses. Before that, we can give others. We have what called bottle lids. Bottle lids. Bottle lids. Number 5, we have bolts. Number 6, we have nuts. All these are examples of screws. Bolts, nuts, bottle lids, screw nails, engineer's vice, and so on. So these are examples of screws. If you look at the bottle lid, inside the bottle lids, there are some screw. There's a screw inside the bottle lid that helps to fasten when you are fastening the bottle, the lid on the bottle. So that's what we are saying. Bottle lid is an example of a screw. So we look at uses of screws. How are screws important in our daily life? How are screws important in our daily life? Importance of screws. Importance of screws. Number 1, screws are used to fasten things together. Screws are used to fasten things together. Look at a pair of compass in your geometrical set. What holds that pencil? It is a bolt and a nut. So a bolt and a nut in your pair of compass, in your geometrical set, it fastens the pencil, so the pencil is tight enough. That tightening is made by the help of a screw, which is a bolt and a nut. So we say screws are used to fasten things together, to hold things tightly together. That's what we mean by fastening. Then number 2, screws make movement upstairs easy. Screws make movement upstairs easy. Screws make movement. Screws make movement upstairs easy. Screws make movement upstairs easy, e.g. spiral staircase, e.g. spiral staircase. We have some staircases which are spiral in nature, like the one in your book. Then screws lift heavy things. Screws lift heavy things, e.g. a screw jack. A screw jack can help to lift vehicles when changing tires. So if you want to change or repair a car tire, you use a screw jack or a car jack to lift the vehicle. So you can say screws like a car jack are used to lift vehicles for repair. Screws are used for lifting cars for repair, e.g. car jack. A car jack lifts vehicles for repair. So therefore it becomes, since it is a screw, that's the role it plays. Then screws help to fasten lids on bottles. Another way of saying screws fasten things together. You can fasten the lid on a bottle. After drinking the water, or drinking the juice, you can fasten the lid on the bottle. So inside that lid, there is a screw there. So that's how screws are important, and that one marks the end of our lesson. May God bless you abundantly, and thanks for listening.